Alright guys, let's have a look at this question. So we're given that x squared plus y squared equals to 2009, and we're asked to find the maximum value of x plus y. So I'm guessing a lot of you, when you see a question, algebra question like this, you will try to manipulate it by either square, and then you're trying to expand it, move things around. But since we're looking for the maximum value here, just by doing algebraic manipulation will not be enough. So what do we do in this case? So in this video, I'm going to introduce you to two methods. Alright, so when we're encountering an inequality like this, the first thing we should be considering would be triangle inequality. Right? But here we're looking for the maximum value of x plus y, and then triangle inequality doesn't really get us to anywhere. So there will be something else that we need to do. So what should we do? So what should we do now? If triangle inequality doesn't work, we need to think of a different way of approaching this question. And I think a very good method when you're looking at an inequality is to consider Cauchy-Schwarz. So what would that be? So the summation of ui times vi squared is smaller than the summation of u times the summation of all the v terms. Right? So in this case, we just need to consider two terms because we just have x and y. And to find the maximum value of x plus y, we can likely find the maximum value of x plus y squared, because using this, we can likely find the max value of x plus y. So what if we let we let u equals to x and then y? So x will be, in this case, u1, y in this case would be u2. So and now we can get this part of the equation, and it will be x squared plus y squared. And we know that given in the question, this equals to 2009. Okay, so at this stage, you really want to think what can I do to make either this part or that part to have a term x plus y. When something has a maximum, let's say if the maximum value of, let's say, m is 2, that means m cannot be bigger than 2. So in this case, we really need to consider how x plus y will be on the left side, because that will actually give us the correct inequality that we want to find. So the left hand side would be and we know that u1 is x. So this is very, very similar to the x plus y squared that we're trying to look for. So we can just let v1 equals to 1, v2 equals to 1 as well, and then we'll get x plus y squared. Alright, so now we can just complete this expression. And then this part, it would be v1 squared plus v2 squared, which is 1 squared plus 1 squared. Thus, x plus y squared smaller than or equal to 2009 times 2. Because given in the question, x squared plus y squared is 2009. And now we can square root both sides. And since they're all positive, it wouldn't affect the sign. We don't need to flip the signs. So yeah, now we just get x plus y is smaller than or equal to square root 4018. So that's one way using Cauchy-Schwarz. So I write method 1. So I think another approach that is very helpful is geometry. So like often when you think about a geometry question, you will probably be expecting, like a graph in the question, but that's not always the case. In this case, we can see that x squared plus y squared, and what would that be? It would just be a circle, right? So we can draw a circle. And this is a circle with a radius square root 2009. Alright. And we're looking for the maximum value of x plus y. So obviously there are a lot of value that x plus y can take because it's a circle. X and y varies and they won't be, it wouldn't give you a constant value. But in this case, I would recommend you to just set the maximum value, which is what we're looking for, be, let's say, k, right? So x plus y equals to c. And what would that be? Okay, so like in this case, we just assume c would be the maximum value. So this expression is just a linear line, right? So c would just be the x-intercept. And we can draw, like a sample line, a sample linear line with the gradient of -1 on this line. It would be, this could be one case, and then this could be a different case. But what we're really trying to find here is a line that can maximize the c value. And since x and y are points on this circle, the line should be touching the circle, right? But to maximize the x-intercept, we need the line to move as to the right as possible. And what would that be? When this happens, it would just touch the circle at one point. Because if you think about it, if you move the line to the right, it just doesn't touch the circle anymore, so it doesn't satisfy how x squared plus y squared equals to 2009, right? But if you move it to the left, like this line, it will still satisfy the equation, but the x-intercept wouldn't be maximized. So that's how the line should be a tangent with the circle. And we also know that the tangent of the circle is perpendicular to the radius created between the origin and the point of intersection. So now we obtain a triangle like this. And then let's make the radius r and make this point m and this point be n. And let's make the origin be o. So now essentially we just need to find the length of ON to find the maximum value of C. And what do we do next? So we can see that we have formed a right angle triangle right here. And then we also know that the gradient of the blue line, the tangent is -1. And with this information, we can obtain the gradient of the radius. Because the gradient of the radius would be the normal of the gradient of the tangent, which equals to -1 over -1, which is just 1. And this is really important because now we know the gradient of the radius of the line created between the origin and the point of intersection. We can actually find this angle, which is tan theta equals to 1. The theta would be 45 degrees. And now we just need to consider the larger triangle right here. If we take it out separately, we get a 90-degree angle here, a 45-degree angle here, and we know the length of r, which is square root 2009, because that's just the length of the radius. And since this is a right angle triangle, we can just find the value of ON, the magnitude of ON, using trigonometry. So cos 45 degree equals to square root 2009 over the magnitude of ON. In this case, magnitude of ON is square root 2009 times square root 2. It is square root 4018. And since C is the maximum value of x plus y, so x plus y smaller than or equal to C equals to square root 4018. Therefore, x plus y equals to square root 4018. This gives us the exact same answer as we did in Cauchy-Schwarz. And I'm sure a lot of people would argue that this method is, kind of slow. It involves lots of drawing, lots of effort. But I do think this is a more intuitive way of thinking it. And this is this geometric thinking is something that you can always apply to. You can always think of it when you're doing the test. I mean, Cauchy-Schwarz is really straightforward, but sometimes it's just when you can't think about it, you just stuck there forever, right? And then this, I think, is quite intuitive and works really nice.